Good morning. Testing, testing. Okay, hope this works. Mic testing. Okay, good morning, everyone. Thank you. Thank you for joining our session today. Let me clear off my screen. I hope everyone can hear me clearly. Thank you for joining us today. I hope everyone's having a good morning, a good new year. Welcome to the first tech webinar by Maxis. Organized by the folks here at Maxis to kind of like reach out to developers, to share some of the stuff we've done before, and kind of like, learn from you as well, maybe create a forum sometime in the future and all that. There will be a series of these webinars throughout the year. I'll be introducing one of the subjects we work on today, digital innovation. So yeah, I guess we'll get started right now. Thank you so much again for joining. We'll take about 35 to 40 minutes. And then after that, we can do some Q&A. Okay, all right, so let's start. Okay, so today I will be talking about the technology division here in Maxis. What's it like to work here, a day in the life of a developer here. The cloud journey we embarked on a few years ago, about 5 years ago, we kicked it off. Lessons learned from that little adventure, and then how we further modernized our infrastructure and code structure, and then how we kind of instill the innovative spirit among all the developers here. So 3 or 4 major topics, we'll just go through them. If you have any questions, just lay them out in the chat window and I'll see if I can answer them. If I can't, I'll definitely get back to you. But yeah, okay, let's go. So before we begin, please allow me to introduce myself. My name is Viki Baarathi. 5/17/22, what that means is 5 years I've been working here at Maxis. I started off as an iOS developer, as a front-end developer. And then picked up AWS, and then I became a tech lead, and now I am the solutions architect. 17 years in the industry, and I've been building stuff for way longer than that, since high school, 22 years. Yeah, so I think most of us tech guys, we're known, if it's in the neighborhood, if someone has a printer broken, they'll call me. Someone has a 10-year-old phone which is slowing down. For some reason, they think I can fix it. The usual stuff. Please pardon, my dog is barking outside there. Okay, so yeah, tech guy, build it, break it, fix it, repeat. I love drones, I love building stuff, robotics. I've been in the automation industry. Really like to tinker with new technologies and stuff. Okay, that is me. All right, there's I. All right, now I work for this company called Maxis. And if you're not aware, Maxis is like the word on the street is it's a telco. We usually use the word telco. The services we provide at Maxis range from your mobile postpaid lines to prepaid lines, prepaid services, your home fiber connectivity, and also an array of enterprise solutions. POS systems, vehicle tracking, and a whole lot of other services. So we aspire to become one of the leading converged communications and digital services provider. Okay, so a lot of solutions for everyone, and we're trying to be the best. Okay, now how do we keep all this going, right? So in order to keep the gears moving, technology is very important. And that is basically the division, the team, the department I work at Maxis. There are various different teams here at Maxis at the technology department. We've got an IoT team, we've got robotics, automation, we've got a cool data science team. We've got our really, really impressive network team, the people who make the voice from your phone convert to the data plan in your services, security team, artificial intelligence team, and digital development. So all these teams are here in Maxis. We all work together. We're all pretty happy with the stuff we work on. And so there will be webinars, I believe, throughout this year on each of these topics or some of these topics. So do watch out if something catches your interest. Do sign up and hope you'll learn something as well, and we will learn from you as well. Okay, now I will be talking about the digital development team. Okay, so yeah, people will usually ask me straight, oh, what is this? Apa ini digital development delivery? Okay. Basically, it's a group of developers. There are about 50 of us right now. It's a bit hard to share everyone's pictures, so we have our own MCU introduction clip. 50 developers, different skill set. We have Android developers, backend developers. We've got React, Node.js, Angular developers. We've got testers. We've got project managers. We've got the whole group, and these developers are very talented, very cool and fun people to work with. Comes from all different nationalities. And yeah, so we come together, all of us, yeah, and we work on the digital fronts. What are the digital fronts? If you visit one of our websites, that would have been developed by one of the teams in the digital development team. Okay, so for example, the Maxis website or the Hotlink website or the business websites, all those are developed here at the digital COE. Okay. Other than the portals, we also work on the mobile apps. So if you are a Maxis user, you may have seen our mobile app, the Hotlink Red app for prepaid and the My Maxis app for the postpaid. And you can do your servicing, your utility service. You can pay your bills, you can top up, you can transfer credit, you can get offers. And all that is being managed and developed here in-house at Maxis. On top of the consumer apps and the consumer websites, we also work on the sales and servicing portals, right? So if you walk into one of our authorized dealers, in the Giant, there's a small booth and Maxis booth and all that, they would be using mobile apps as well. These apps would sign you up as a Maxis customer, do the background checks, scan your IC, and let you choose what line you want or what mobile device you want to buy. All those apps are also under our care. We've also went on to build self-serve mobile applications, which allows you to pick a SIM pack off a 7-Eleven store and activate it yourself. So a lot of these apps are under our care. We work on them in an agile manner. And altogether, there are about 30 plus apps and services, all handled by this group of 50 developers, young and talented developers. So how do we do it, right? So today we've got all these developers and we've got our project managers and we've got our testers. We still manage to keep up with building and improving 30 applications, launching them on time. Every 2 weeks we release, keeping the code really clean and keeping the code really consistent. We've come a long way. We started off with one, of course, 5 years ago. But all that took some time, and we kind of have like a architecture right now. So we mainly work with AWS. Other divisions do work with different cloud technology as well. We have Google, we have Azure. Mainly for the digital team, we work using AWS. So all our apps are hosted in different kind of services, different kind of resources. We're also big on open source technology. So we kind of have everything set up. So what we want to share today is how do we get here, right? Like I mentioned, I was originally an iOS developer. I had no idea what this cloud thingy was and all these colorful icons, a baldi here and a brain there and gajah there. And I was like, well, what is all this, right? So it took some time to learn it, but once you learn it, everything is really fun and really cool. And you can really expand your growth with all this knowledge. So let's begin. So how do we get here? How do we move 30 apps and continue to build them and deliver to the business on a timely manner with high quality? Right, so let's start with the journey to the cloud. before I do that, okay, for the benefit of some of my friends or some of the audience who join the call without any knowledge, without any development background, let me just give you a very brief introduction on what this whole cloud thing is. Okay, so traditionally, if you were to host, or if you have a mobile app, or if you have a website, you would host your actual website on a server, right? And you would own that data center, or you would have someone manage that data center for you, okay? So when you have your mobile apps on the top, so if you got 5 users connecting to your servers, yep, that's fine, right? No problem there. Now, if you remember, a long time ago, certain airlines would have promotions and all that, right? And right at midnight, everyone would go and try to book a ticket, right? What would happen? When the traffic really hits, the servers would actually go down. Now, the reason for that is because we kind of manage the servers. We bought 3 servers and that's it. We kind of calculated, oh, we're only going to get like maybe 5 users a day. We were never expecting like 5,000 users suddenly, right? So when that 5,000 users came in, we wouldn't be able to scale, right? So that was a common problem before the cloud. You would either have to invest upfront lots of servers and just pay the maintenance and electricity bill, only to hope for massive surge, like maybe 1% of the year, right? So it was inefficient, and the management, the maintenance was extremely high. Also, you'd have to literally take care of the servers. You have to manage the air conditioning. What if banje or what, you'll lose the service, right? So it was difficult. It was very expensive. Then the whole cloud thing happened. The difference is you don't have to buy your own servers, right? You're basically renting the servers from this company called AWS, Amazon, and they will provision the servers for you on their data farm, on their data centers. You just install your application on their servers. You pay for the time you consume them, and then that's it. You don't have to worry about maintaining the servers, or if the building burns down or what. AWS will manage that for you. So if you've got 100 users throughout the year, that's fine. You just spin up 3 servers, for example, right? But let's say you're going to have a Christmas promotion or something. The idea is, by using the cloud, is when your traffic hits, you have the opportunities to scale, to simply just spin up more servers or kind of expand the usage of those servers. That was the idea. Hold on, my light just turned on. Okay. Yeah, so that was the idea, right? So we wanted to try that. Why not, right? Let's give it a go. Instead of us managing our servers here in the Maxis data center, let's go to the cloud. So we picked our primary app, Hotwing Red app, very popular app. It's the prepaid app used by the prepaid customers, and they can buy passes, data passes, and all that. They can top up, they can check their balance, they can look at deals and all that. And originally, we had 12 very powerful servers, all on-prem. I mean, on-premise, pardon me. And these servers, well, they work traditionally, right? We would actually get an average of around 8,000 users at a moment per day, like at a moment, right? Active users, 8,000 users. They'd be buying passes or sharing credit and whatnot. However, once we go above 8,000 users, these 12 very powerful servers will start to hit like a maximum load. When we reach 10,000 users, that's it. It's the end of the day for us. Recovering them would be difficult. The servers would hang, and it would be very difficult to kind of bring everything back. Not to mention the experience for the customer, right? Every time midnight, we have a demographic who loves to buy the midnight passes. Midnight, our traffic would just spike. So it wasn't a good experience for the customers as well, because when the traffic really hit, things would go down. So, okay, let's plan it out. We spent about 5 months or 6 months trying to learn AWS. We partnered with AWS themselves. They had workshops. They taught us how to spin up the resources and all that. There are multiple ways of going to the cloud. You could start from scratch, throw away all your code and just rewrite everything, but that's going to take time, right? The other method is to simply just lift and shift. That's a common term used out there. And people usually ask, is it good to lift and shift? Well, I'm going to tell you. We did that. We blindly just lifted and shifted, right? So we just moved on. Instead of paying for our servers now, we're paying AWS, but nothing changed in the code and nothing changed in the way the code functions or the way the servers talk to each other. We had 12 servers before, we have 12 servers after. So now we have 12 servers, powerful servers. What do you think happened? Do you think the cost went down or the cost went up? Right? Well, just fill up the comment if your chat window is open. What do you think happened? Well, actually, the cost went up, right? So it actually does cost more. But what about traffic now? So the whole auto scale, the whole scaling thing, right? Okay. Well, that's what we did. When we needed the traffic, we would actually just spin more servers. Double the servers, double the users. But it also means the cost would skyrocket up, right? Some would say, hey, that's okay because my customers are going to be happy. So that's where we ended our first phase. We just spun up more servers. Customers would actually not have the app crash. However, it was very, very, very expensive. Why stop there? So we decided to actually go back to the drawing board and start studying more on AWS technologies and how we can improve. Apparently, we can. There are a lot of services in AWS which you can use that would help optimize your costs or the way your app functions. And that came into the modernization phase, okay? What does that mean? All right, so we have our 12 original powerful servers. Apparently, we don't have to do everything ourselves. For example, a database, right? Typically, traditionally, we would install the server, we would install the database and manage the database ourselves. If the database crashes, that's on you. You'll have to go figure out how to back it up and restore and whatnot. AWS has a lot of features where they will manage everything for us. You only pay for the amount you use. So it's pay per use. You only use based on the number of people who connect to your database, for example. So we started identifying business logics in our application and started splitting them up. So some of the rapid transactions, we put them on this NoSQL DynamoDB, lightning fast and super cheap. All our media stuff, we put on the S3 bucket, the Baldi thingy. And that really cut down the cost of transmitting static files, like those images and all that, right? Putting it on S3, putting it in front of a CloudFront really cut the cost down. And at the same time, improve the performance. So we went on this modernization journey, and half a year later, we were able to really see differences, right? So from the original 12 servers, we now only run about 8 servers with the auto scale implemented, meaning when the load hits, we don't have to go and click something to scale the servers up. They'll just scale. And when the traffic leaves, the servers will just shut off by themselves. That was good news for us. So from an average of 8,000 average users, at a moment, that average actually increased. More people started to like and use our app. And today we have at one time about 14,000 users at a moment. Now, please bear in mind, Red App came way before. It was 5 years ago, right? So it was before the Grabs and the Shoppies and all that. And today, if there's a promotion or if there's any special marketing or whatnot, we could still go to 20K with a bit of auto scaling and counting. We've never actually had it hit any maximum capacity yet. We've also noticed a lot of improvements with speed and logical performances as well. So that's our journey of how we moved our originally first app into the cloud, and then we started breaking it down and started changing the architecture a bit. From this learning, so we did one app first. We picked one app and we did the experiment first. We did it on the biggest app, by the way. And then we went on. So we've got our authorized dealers who use the sales app, which I shared before. We started to move all of these apps, lift and shift, plus a bit of modernization, and go to the cloud. So when we had something like this, for example, each app had its own login logic. Each app had its own customer identification logic, or billing or registration, right? So why have the code in 3 different places? Then you'd have to maintain each one each time. So that was the idea of building microservices. We would actually identify what service could be shared across different applications. And basically that was microservices. We started building based on the use case. We had to carefully study and identify what use cases could be shared, right? So we had login microservices, we had the customer identity, we had billing. So basically all the apps would require the billing service, right? Postpaid needs a billing service, or prepaid needs a billing service. They can all just consume the same microservice. They are separated. And some of the other benefits is if, say, one of the services go down, say the billing system in the backend goes down, right? Well, the entire app wouldn't crash. The app would be pretty much still functional, just that the billing functionality may be down. That's it. And that's one of the wonders of building it in small little chunks and small little functionalities. However, we still had to be careful. This can grow pretty wild. Once you start building lots of microservices, you can actually get lost in the spider web if you're not careful. You'll actually lose track which microservice talks to which other microservice. From 5 or 6, we have like 600 now. But it's pretty vast and it's pretty well documented. So one lesson here is that we have to really be careful with how we design microservices. So for that, we had to like lay the foundation again, like really figure out a process on how to manage everything. So we put our DevOps team together and we practice Scrum. Okay, Scrum is a project management methodology, I guess. It's from the Agile methodology. It's to work fast, fail often, and fail fast. That way you can inspect and adapt to change very quickly. So we use Jira and Confluence to manage our development process. Business will give us a requirement. We will have a grooming session where we sit down with the team. Each team has their own Scrum process, or Scrum team actually. So they will all go through a grooming session, identify the user requirements. The tech lead would actually break it down and kind of design the solution for the developers to work on. So all these user stories will be on Jira and it will be picked up at the next sprint. So we have a 2-week sprint process. The developers will spend the 2 weeks building the application or building the feature in the application. And we use TeamCity to manage our DevOps. So as you send a pull request, as you send your code to be reviewed by another peer, if the review passes, the code is compiled automatically and deployed into the environment. So there's no need for manual compilation of the code and stay up late in the evening and deploy the code. Everything is automated. Now, we still have some ways to go. It's not perfect. We still have a lot to learn and a lot to improve on all these pipelines, but it is pretty interesting. So yeah. Okay, so we have our DevOps and Scrum processes in here. So that's how we function, right? So we started off with pushing things to the cloud, and we started breaking things down into microservices, and we've got our DevOps, and we're still learning, and we're still trying to figure things out. And I put together some tech tips today for like a takeaway thing. What can you take away from this? Okay. All right. So if you're gonna do any of this, if you're gonna embark on your cloud journey, give the team enough time to familiarize with the cloud. There's a lot of things to learn. You can actually work closely with your cloud partner. So AWS, Google, or Azure, or Ali Cloud, whoever, they have workshops and they have courses. Do join them and ask them as much questions as you want. Understand the well-architected framework. They will teach you how to kind of design a proper application, enterprise application structure, security and application, what responsibility do cloud vendors take, and what is your responsibility as the application developer. Okay. I would always recommend lifting and shifting plus modernization in phase one itself. Don't do what we did. Take the time to study, identify the areas which can be swapped out so that AWS can help you make things quicker and easier. So you kind of need to know how big your team is and what's it like to actually manage everything once it goes to the cloud. All right. And the next one is microservices is kind of like the fun word right now. Everyone's, hey, microservice, hey, Viki said microservice, let's do microservice. Be careful though. Monolith, breaking things down from monolith to microservice may not be for everyone. So you do have to study your use case, and you have to study your audience, your traffic, what kind of users are there. If you have a small team and you have a small application, and you have a small number of users using it, then maybe you don't want to trouble yourself with managing a web of microservices, right? Then still maybe monolithic is still just the way to go. Study your design carefully and make the decisions accordingly. It can cost you a bit. So understanding the cost from the beginning, you have to study what AWS offers. It can be very weird, the way they calculate the costing. Some is based on capacity, some is based on traffic. So you'd have to sit down and really calculate the amount of traffic you have before you actually can figure out what your budget is like. And that's another thing, right? Typically, traditionally, you just put in a budget and then you get the budget and you use. But if you build your apps correctly, it's pay per use. You only pay for when your users visit your apps, right? So figuring out what the costing is very, very important. Okay, number 3 is work very, very closely with your cloud and security teams. We had a hard time with this. We really had to figure out how to configure the networks really securely. They have these IAM policies where you tell this service can talk to this service and no one else, right? So having all those security in place is very important. Do it in the beginning. Make sure you have a strong discipline right in the beginning. Otherwise, you're going to have a hard time maintaining it once you get too big. All right. So yeah, again, sometimes it's easier to just set it up on your own, and sometimes you can just use managed services. Also, again, a lot of material from AWS. Like the database is a big example. It can be very difficult to manage a database. So you might want to just hand that off to AWS. Also, when designing your microservices, you need to be very careful not to accidentally build a monolithic microservice. Sometimes one microservice will just grow and grow and grow, and while all the other ones are like cheapo microservices. So be careful on how you design, identify your use cases, and kind of break them down accordingly. So that's the whole cloud migration and the whole microservice initiatives, we're using a lot of tools from AWS, Kafka, and we recently used the managed Kafka service. That's working out pretty well. We use AWS CloudFront and S3. We use the container service to deploy our Fargates. Very interesting stuff. It makes the speed of development amazing, right? So as developers, as innovators, we don't have to worry about, oh man, where am I going to get a server from? I need to host this, I need to host that. I can really focus on innovation. I can really focus on building the application. Don't have to worry at all about where the servers come from. The cost for someone who has to worry about it, but I can really focus on the application. Okay, so if you have any questions, just feel free to just pump it into the chat window. Now, so right here in the digital team, everyone is encouraged to learn about the cloud. Everyone is encouraged to try out the new services. And that's when suddenly, out of nowhere, we kind of had this innovation initiative going. Our leadership is pretty cool. Our CIO and the head of digital, they're all pretty cool people. They really encourage developers to try out new things. Yeah, don't know whether it's function or not, never mind, do first thing later. But yeah, we have POC accounts, we have POC resources. A lot of these AWS resources, they have a free tier. When it's a POC, there's no traffic, right? So you barely pay anything, like cents. So we are heavily encouraged to try out new things. And I'm going to go through a few of our examples. So besides the Maxis business applications, the websites and all that, right? Those are all BAU, right? So the boys, the girls here at COE, sometimes want to figure, want to do something new, right? Okay, so once upon a time, 2 years ago, a group of product owners, business analysts, and developers came together, and they wanted to kind of figure out how to elevate the retail experience. If you go to a Maxis store in Mid-Valley or what, before, a long time ago, you would notice that you would have to queue outside first, and then you go in and queue in again. Very weird. So that was a pain point captured. The queue system before was extremely boring. It was extremely long, right? So how do we elevate that? And one of the solutions among the whole program is to create a more immersive experience using a digital queue system. And that's what we came out with. The boys were like, okay, let's just take out the paper system and let's build something. Now, go check out AWS Amplify. AWS Amplify is a front-end framework which allows you to quickly and rapidly create your proof of concepts. Okay, so if you have one developer and you use AWS Amplify, you can spin the database up, you can spin the APIs up, you can spin the front end and host your front end, everything very easily just using CLI, just using the command line interface. However, take my advice, it is for proof of concepts. Think carefully before using such rapid prototyping tools for your production, okay? But nevertheless, we managed to do it. We pulled it off. So within a month, we were able to create a digital queue system. So today, if you go into one of our Maxis stores, you don't take the paper number anymore. You would scan a QR code, and you would get your number on your phone, your ticket on your phone. And when it's your turn, you actually get the notification and the SMS to go see your retail representative. So that was cool. That was fully serverless. It was very lightweight. On top of just a boring paper, we could actually feed information. We could feed banners, promotions. And because everything was built in microservice manner, we could easily implement new features without breaking our original application, right? So we we could easily start off with an MVP, with a first version, and then we started adding up more features. So if you go to the store and you take a queue using this digital queue system, you would actually see banners, you would see offers tailored to you, personalized offers. You can make appointments. You can actually join. If you have the VIP status, they will calculate and they will actually push you up the queue. And lots of other features as well. Leads, opportunity capturing, and all that is all inside. Okay, so that was pretty popular, and this app continued to go on to be deployed. It was originally a proof of concept. It worked. It was easy to deploy. It was easy to scale. It was completely paperless. And today it's being deployed into all of our retail stores. Now this, again, I remind you, this came out of some of the developers as a part-time project. And the leadership is cool enough to actually let us pursue this. Well, we didn't stop since then. Another thing which you would see usually at retail stores is that price card paper thingy. Yeah. But there was this age where we want to go paperless, right? So we want to reduce the use of paper printouts, which needs to be replaced if you have a different offer and all that. And the paper can't really convince. Paper. No detailed information about the stock and so on. And we went on to build the Discovery app. So some of the developers argued that, front-end developers, by the way, we have this debate of native developers, native app developers, and hybrid developers. And always there's this debate. So fine, you want to prove a progressive web app works? Go ahead. Here's a demo. Here's a POC app. Here's something you can work on. Go ahead and build a progressive web app, right? So this app would integrate directly into our commerce engine, and this app is configurable. So today, if you go to a Maxis store, there's no more paper card on the table anymore. You will see those demo devices on the table. And there is an app on those demo devices itself, which will actually pull the data from our catalog and display the pricing of that device directly. Yeah. Okay. Yeah. So basically, the app can give you more information than just a piece of paper, and it can also capture your interest. So what's pretty cool in this scenario is, so if a customer walks in to the store and he's shy, he's shy. He doesn't want to really talk to the staff behind the counter. So he goes on and he picks up a device. He looks at it, and the Discovery app will appear. The Discovery app will ask him if he's interested, and what will happen is that information is picked up and sent into the Mira system, the queue system before, right? And when it's his turn to be served by the sales rep, the sales rep will already have that information. Hey, this guy was actually interested in the iPhone, so now I could upsell or cross-sell. So these are all in the Maxis stores already. You can go and experience them yourself. And these two functionalities are continuing to grow, right? So if you're now browsing on the website, on the commerce website at home, and you pick a product and you have, maybe you're not too sure of buying it from home and you want to go to the store, to get more confidence, we're kind of building that end-to-end journey today. So from the store at home on the website, you will connect to Mira as an appointment, and you can be served in the store as well. So all this room to innovate and to create cool things, it's really open for us to explore, right? And we didn't stop there. Why stop there? Why stop at a mobile application? Let's take it all the way. So AWS had this Sumerian technology. Basically, it's augmented and virtual reality platform. We created this 3D avatar, which is on the screen at the store. It uses a vision technology to kind of maintain eye contact. So if you can notice, she will try to look at you based on where you stand at the store, right? So that really got a lot of attention from people. So you have this character standing in the store, greeting you, saying hello. There's a speaker up there. We use AWS Poly and AWS Lex to translate. It's the chatbot plus the voice system to give her a voice. Right. Again, she's being launched on iPads and it's being launched on all the stores around the nation. As for VR, well, we did some. This one's not launched, but it was a prototype we played with, kind of seeing what we can do with the 3D environment. Maybe create like a virtual store or something. Again, all the opportunities are open for the developers. Whichever they want to learn, whichever they want to experiment with, they are free to do so. So this was a really cool experiment. And with the whole metaverse going on today, maybe this could be something, never know. But nevertheless, it's always encouraged for people to try new things. Okay, let me leave her alone. One of the other cool things we did over the last few years is release the self-activation mobile app. It's called Daftar, and it's on the Play Store and on the App Store as well. Before this, you would have to go to a Maxis Center and buy the SIM pack, and someone would activate for you. Now, being able to, since we built the app for the retail store, we figured out why not we expand that, right? So we built a self-activation app. We use OCR technology and face comparison technology using machine learning. And we were able to allow customers to kind of lift up the information from your card and do a face comparison and a liveness test. And then all this information will be submitted into the backend to activate SIM pack. So if you go to a 7-Eleven today, you can pick up a SIM pack and you can activate it yourself. During the MCO period, this helped a lot because stores were closed, so people just had to order them online on Lazada and whatnot. And the SIM packs would be sent by mail, and you can activate the SIM packs yourself. So this was a really good example. This was a really good example of innovation. Originally we worked with a vendor, but eventually we figured out that we could use our own technology. We could train our own models. We could use some of AWS managed services. They have recognition, they have text track. We made use of those APIs as well. And we managed to successfully create a fully web version. So you don't really have to download the app, but you can actually just have a seamless journey from the web. So if you're browsing on the web and we need you to verify your identification, the eKYC system is seamless. You don't have to go and download the app. Try it out if you ever want to have a look. But you'll have to buy something on the website. Some other proofs of concept is perhaps we could use face verification to identify a customer. This one hasn't been done yet, but we typically have this problem where someone forgets to bring their identification card, right? Now, using the lessons from our previous experiments, perhaps we could do a face verification, face comparison with the information we already have, right? Then we can identify whether the faces are similar, and then let the customer in. So as the customer walks in, perhaps we'll already know him, right? Like really know your customer, and maybe that could be something. Now, these are all experiments. These are all just proof of concepts, but perhaps it's something viable for the customer, right? Way to lift the customer experience. Okay, so where am I now? Okay, now this one's pretty cool. So a few years ago, one of the managers who is in charge of our cell towers, right? He manages the folks who risk their lives climbing up the cell towers to do the maintenance. And he was like, why don't we just use drones, right? Okay, so yeah, let's try it out. So a group of us got together. They bought the drone. A group of us got together. We used the DJI SDK to kind of build our own autonomous flight rules. Let me see if I can play this for you. It's still in the lab. It was just a proof of concept again, but we could actually program a drone to autonomously detect where the towers are and fly around it, okay? And fly around it and take high resolution pictures. And then we use machine learning, supervised learning, we train a model to identify if there are any screw looses or if there are any rusted components, and then feedback those information back to the engineers to survey. So they don't have to climb up the tower all the time. They could send a drone first to kind of inspect and use machine learning to kind of tell you, hey, yeah, there's a screw, there's a bolt missing, and so on. Again, this is an internal thing. It was a fun project. Perhaps maybe one day we could further grow this, and maybe we could do something really cool with this in production. Okay, so that's the drone stuff. Now, yeah, so I've been just sharing with you some of the stuff that allows us to try out new things, right? Not everything is about work. I got this message from my CIO the other day: play together, win together. Yeah, have fun with the team. And that's what we try to do here at Maxis. Every now and then we'll have town halls, and we'll invite folks to showcase their own projects, develop their own stuff, and just show it off. No harm in that, right? Oh my, let me read slides. So this was a simple prototype we built just for fun, right? No application. It's a simple robot, which takes a picture of the IC, takes a picture of the SIM, takes a picture of your face, and then kind of like puts everything together, and then make sure that you are the person in the document, picks up all your information, and activates the SIM pack, right? So this was just a fun little project. We played with AR technology. So if you could imagine someone hovering over a mobile device, potentially we could actually show all the web content on top of the device. So imagine a time where you would walk out and go to a shop, and then you see, oh, I got a new Samsung device. I wonder how much it would be at Maxis, right? So how our app on top of the device, and then display the pricing from Maxis. Proof of concept, just for fun, right? On top of that, we also have our own hackathons and our own internal tournaments. Some of you may have heard of the AWS Deep Racer program. The Deep Racer program was introduced a few years ago, actually. It's a way for AWS to get people to be excited about AI and machine learning. It uses reinforcement learning. Okay, so basically how it works is you don't control, it's a race car, by the way, it's a physical race car. Yeah, I have it down here, but I'm not going to pick it up. It's a physical race car. You don't control it with controllers, no. But what you do is you use your computer and you train an AI model. You teach it how to drive. Do you teach it how to drive? No, you kind of let it learn by itself. Reinforcement learning. Now, how do you do that? Basically, you tell the car that if you ever leave the track, I'm going to reduce or take away points from you. Okay, it's all about points. This model apparently likes points. So if you go too fast, I'm gonna take away points. But if you stay in the road, I'll give you a point. At the corner, if you take a slow turn, I'll give you a point. If your left wheel ever leaves the track, I'm going to take away a point. So you can program this program to learn how to drive based on the reward function, which you can formulate yourself. So developers would train the model to gather as much points as possible. And in the simulator, not the physical car, in the software, this virtual car would go around. It would start off wonky. It will just hit the tree or hit the side, and it will get 0 points, right? And then after thousands of iterations around the track, this virtual model will actually figure out, hey, if I drive like this, I'm going to get more points. If I stay on the road, I'm going to get more points. The model is going to figure out how to do that. And once you like the way your model performs in the virtual simulator, you could actually plug that out and put it into this car. And there are international tournaments on this. You could actually put it on the physical, and you can go to all these tournaments all over the world actually. But this was all before MCO. Impossible this is going to happen now. But anyway, yeah, this team building was before MCO. So we thought, the group of us, why not we have our own deep racer tournament here in JLCC in Menara Maxis. Then we saw the cost, and it was like $20,000. We would need to get movers, and we would need to get a permit to use the cargo bay. We need to get insurance and all that. No way I'm going to do all that. So what do? As always, we DIY ourselves. Bought some gym mats from Shopee and some masking tape. And a week later, we were able to kind of create our own racetrack. So we borrowed some cars from AWS. AWS themselves came down and gave the briefing and the training. That's my car with all the track inside. And we had the entire company, the entire technology division, actually, 1,000 of us, or 300 of us, formed teams of 10 and trained their models and deployed on their cars. And then we gave away prizes, and it really got everyone excited and really, kind of introduce everyone to machine learning. Okay, so the outcome was pretty cool. Like I said, everyone had. This is an example. This I guess was the winning car. Now back then we were all pretty new, so we weren't that great at doing this. But yeah, as you can see, the car actually drives by itself. No controls whatsoever. There's a camera there, it's looking at the road, and it's figuring out how to go around the track. Really fun, got everyone really excited. And that opened up more doors for us to explore new stuff. Now we're picking up machine learning and AI and how to, and that's basically when we started to do the whole face recognition and the whole AWS text track thing. Okay. Oh, by the way, I forgot to add the slide, but I think a year later, the guy, 3 of us from this whole big group actually went on to get the first runner-up, 2nd place at the ASEAN Deep Racer League. So that was pretty exciting as well. Okay. Hey, all right, cool. I'm coming up to the end of my session. Okay. Okay, so how do you innovate? How do you inspire your team to innovate? Having a strong and supporting leadership team is very important. I openly tell my leaders that I love to do all this. So you should too. Go speak to your leader. If you want to try your new things, don't be shy. Tell your bosses and just try to get something. Try to get something, a proof of concept out, right? And same goes with your leaders. Encourage your employees, encourage your developers to try out new things. It does wonders. You can sometimes learn more from a proof of concept, which you worked on for a week. You can learn more from that than you could over 2 or 3 years, right? So I feel sad sometimes when I see a developer who's just writing the same .NET code for the last 5 years. And that's one reason why I wanted to do all this. I wanted people to know that there's all this opportunity of growth in the space of technology, right? And the cost of doing it is all very cheap now. It's all very, very easy to do now. So speak to your leadership, and leadership, please speak to your employees and try to encourage everyone to try out new things. All right. Okay, but I do have to warn you. This was my problem. Always think about production. Mana tahu your boss will say, fine, okay, you do already, POC, when can go live? That's a scary thing, right? So always think about production. Always put the caveat down. This is a proof of concept. It cannot go into production because you need to figure out the security stuff. You need to figure out who's going to actually build and maintain it, all those stuff. So always think about your proof of concept if in case it's going to go to production, right? Have fun. Don't be afraid to fail. and don't be afraid to try new things. And don't over-engineer, right? So always start off with something very simple, like the queue system. That Mira thing, right? The first version, you scan the QR code, you get a number. That's it. Just get a next running number. That was the first MVP. And from there, it grew into now you have priority queue, you have appointment systems, you have machine learning offering you personalized offers and so on. So start off with something very, very, very basic. All right. And then usually you have those naysayers, right? This one got ready lah for what? Don't listen to those folks. Just do it. Just do it, even though that solution is already there. But the feeling you get from building something yourself, right? Even though you're copying it over YouTube, you looked at YouTube exactly and you're just building it again. Trust me, that satisfaction you get at the end of it is worthwhile. So people would say all sorts of things. I don't need that. Don't listen to them. Also, there are those who fear the unknown. Okay, it's fair, right? Some people will try to be a bit more protective, and some people fear that later it will cause problems. It's fair. Yeah, still, go ahead and try new things. But if it is something that needs to, you really need to figure out how to solve problems later, then come up with a plan, or have some backups. As this whole Murphy's Law thing, right? Everything which can fail will surely fail on. So like the whole drone thing, it's a lot of research. Drone can fall off into someone and all that. So that's why we are very careful. We don't just simply go build it and start flying it everywhere. No, we're being very, very careful. We have try to come up with better plans on how to continue to build. And then one last thing is the most important thing is, what about cost, right? AWS themselves have an amazing free tier program. So even if you have your own AWS account, a lot of the services will be free for a certain usage within the first year. Use that. Or if your company is partnering up with AWS, one of the AWS guys was supposed to be here today, but unfortunately he couldn't make it. You can discuss with them. Discuss with your cloud provider on getting credits or working together with them on coming out with any proof of concepts. Again, one final note is go speak to your leadership again. My only message is that if you try new things, if you keep playing with the technology, you're going to learn so much and you'll be way more confident in delivering all your features in production. Okay, so basically that's all I have. Thank you. You can email me if you have you can get in touch with me via email. I'm trying to get my whole Twitter game up, so please follow me at Twitter. I'm really trying to figure that out. I hang out at this Facebook group called Developer Kaki. So if any one of Developer Kaki gangs are here, hey, big shout out, thank you to you. Yeah, just search the name Developer Kaki on Facebook. There's about 18,000 developers up there. And all of the folks really talk really cool and interesting things. They discuss really fun stuff. It's also a way of really improving your knowledge when you meet all these developers, right? Okay, so thank you. So my hope again is to kind of bring together the developer community, right? Just to get everyone familiar with each other, kind of understand what all these bigger companies are doing, what the smaller companies are doing, and perhaps kind of build that digital future for all of us, right? For all especially the Malaysian developer community. Thank you so much. Let me see if there's any questions. I need to switch the window. Give me a moment. All right. Okay. So I've got this. We're still not adopting eSIM. Yes, we are. We're adopting eSIM. We already have eSIMs going on today. But it's still not automated. You still have to go to the store and say, "Hey, I want an eSIM," and they will do that transition for you. In the future, perhaps we could actually automatically activate your eSIM, but it's still in progress, right? So the question was, why still not adopting eSIM? Yep. Okay. So if you notice your iPhones especially, anyone has an iPhone. Actually, iPhone has a built-in eSIM capability. So you could go into a Maxis store today and you can ask for eSIM. And what happens is this becomes a dual SIM phone. You can throw away your SIM card and it works pretty well. Second question is, why not install cameras on the towers? Then it's going to be a lot of cameras. And we'll have to maintain the cameras, and we'll need to fly a drone to inspect those cameras then, right? Again, innovation takes time. Sometimes we don't know what we're doing. We'll have to figure out on the way. We'll have to see whether it's logical, whether it makes sense, all that stuff. This drone project was AKA the Sky Eye. Yes, that's right. I guess you've heard of it. The drone project was named Sky Eye. How does the movement to cloud start in Maxis? Do you have super CTO, CIO that understands the importance? Yes, we had really strong leadership, and they really pushed us to move everything to the cloud. I wonder if my CIO is here. I can't see the audience list, but yes, we had strong leadership. The question is, sorry, I'm not used to reading the questions and replying, so I'm a bit new at this. Okay, so the question was, how does movement to cloud start in Maxis? Do you have super CTO, CIO that understands the importance of moving to stay, scale, and innovate, or someone from the bottom start to preach? From my experience, it was my CIO. She really pushed us. She really encouraged us to check this out, and so we did. Okay. Do we have any other questions? Okay. All right, good. Another question here. How do you choose between AWS Lambda or EC2? How do you choose between AWS Lambda or EC2 for microservice? Okay, that's a good question. How do I choose? Okay, my answer would be this. Okay, so by the way, EC2 is like a server, the one on the orange boxes like earlier on. EC2 is it's a physical server, right? So you pay for the time you use. It's charged by the minute. It turns on and it's on the whole night, and then you just continue to pay. Lambda is like a super lightweight function, lightweight compute. It can run for 5 minutes. It can do a bit of calculation for you, and then it will go to sleep. Yeah. So how do you choose? Okay, my answer would be you look at your application, right? And you look at your users. So what kind of users are you going to serve? Are you going to serve one CIO who's going to use your app once a day as a dashboard? Or are you going to serve like millions of customers 24 hours a day? Or are you going to serve customers during working hours, 8 to 5 p.m. kind of thing? That's the first question. What kind of users you have? The second thing is you want to know what kind of compute you need. So maybe it's an API, right? So whether this API is going to do a lot of data crunching. So if you're going to do a lot of data crunching, then you're going to need a lot of resource, a lot of CPU, right? And the amount of time you need to compute your program, right? So if, for example, it's an API you want to do face recognition, right? And that's a lot of heavy things. It's a lot of calculation. It's a lot of math, a lot of programming. So you kind of want to identify those spots. So if it's like EC2, then it has way more memory. A Lambda only has a 5-minute lifespan and it has limited memory power, right? So you depends on that, right? So if you have millions of customers throughout the day and your compute is extremely heavy, then you go towards EC2 or Fargate or something which is robust and very powerful. But if your compute is very lightweight and it only needs to run just for a few seconds each time, then Lambda would be your choice. Or if your usage is only during the working hours. At night, nobody's going to use it, right? Then again, Lambda is your choice, because at night, nobody uses it. You don't get charged for it. Everything is free. Yeah. So that I hope that answers your question, right? So depending on your customers, depending on your logic, depending on your compute time, depending on the memory usage, that's how you pick which resource you need. Okay. What are some of the challenges you face as a developer? When exploring the user, how do you find ways to overcome those challenges? Well, okay. What are some of the challenges you face as a developer? Documentation, examples, of course. When you're doing something new, you can't really Google and find out because there's not much documentation on it. AWS Amplify, when it first came out, version 1, there was literally one single documentation. So how we figure out it's trial and error. I would typically create my own AWS account, a side one, a small one, a free one, and just hammer it out there. Just keep on trying until I figure something out. Otherwise, you could always discuss on a lot of developer forums. There's always someone willing to help. There's a lot of Discord channels, Facebook groups, and the AWS groups as well. Okay, I find very little documentation. How did you grow your expertise in that area? AWS Sumerian. AWS Sumerian is that 3D thingy, right? A 3D environment, right? Actually, how did I go? Well, it shares similarity with a gaming engine. Yeah. So if you've ever heard of the Unity gaming engine, that's a popular gaming what do you call IDE or framework to build games. You can manipulate 3D objects, create 3D objects on that. It actually shares similarities on that. So if I don't know a certain technology, I try to find out what the root is. What is it based off? So Sumerian is based off very typical and very standard 3D environments. So I actually cross over and try out Unity first to understand how lighting works, how physics work in the virtual world. And once I get all that, then I can easily pick up Sumerian. Yeah, that would be the answer. With innovation POC, you mentioned to try, make first, and think later, to fail fast and learn fast. On how long we should spend on POC. How long we should spend on POC. Well, it depends, right? So some things, okay, so if I were to do a POC, let me see now. The virtual reality stuff, which I'm doing right now, which I'm playing around right now. I'm trying to build apps for the metaverse. I don't know how to get it on here, right? So I back off the POC first. The game is not coming anytime soon. I need to go really figure out how to deploy to this efficiently first. You know, I work backwards. So I write my final goal, what I want to deliver. This is also an AWS methodology, like working backwards. I write what I want to achieve, and then I kind of work backwards. So step 1 is really to figure out how to deploy stuff into goggles, right? So I get mini POCs, right? So my first mini POC is to just efficiently deploy stuff onto goggles. So I break it down. That's why like the whole POC is now broken down to mini POCs, and each mini proof of concept should be very, very fast within the weekend. Yeah, usually I give a weekend benchmark. If I decide, like, okay, this week I want to figure out how to fly a drone, then I'll spend this one weekend trying to understand, watching YouTube videos, reading some documents. Usually the 2 days should give me some fundamentals, and then I take it to the next step. What can I do with the drone? All right. Then next weekend, I'll maybe look into how to autonomously fly something, how to deploy autonomous code into a drone. So I do small little chunks and see where it goes. Yeah. If I put everything I want together and I say, oh, this is going to be a 3-month POC, the motivation will die off. Yeah. Okay, in your opinion, do you see metaverse use cases growing, or is the metaverse just a phase that may die when something more exciting comes up about? Oh, you won't know. The whole smartphone thing happened when Steve Jobs introduced the iPhone 4, people said the same thing. So would the iPhone be a future, or is it just a phase of a glass screen? People ask the exact same questions. You can find lots of funny memes of people back then uh, sharing emails where the iPhone's useless. But look where it is today, right? Cryptocurrency, people say, what nonsense is this blockchain and Bitcoin and all that. It is a multi-billion-dollar industry today. You don't know. You never know. Metaverse isn't new. It's been around for quite some time. Actually, people have been using it, but our Facebook friends decided to kind of really go aggressive on it and rename their company based on the word meta. So it's blowing up right now, no doubt. But where it goes, we don't know. What you see is probably not the future. The future is basically some hybrid of this, right? I think they're already building it. So these goggles, if you've seen all those 5G advertisements, everybody wear goggles and do stuff, right? But these guys already put cameras here, right? So maybe the future is mixed reality, where you put your goggles on and then you see what's in front of you. At the same time, stuff will be projected inside the goggles for you. We don't know where it's going, but we keep up with the news. We keep up with what's being built, and we try to understand it. Then we can stay up to date. All right. Oh, there's one over here. Yeah, I did. Which deployment are you using for Microservices? EC2 or Fargate, and which Docker? Well, we are using both. So last time we used to use the Docker ECS and have it on ECR. We would deploy it on EC2 last time. But recently, we also use Fargate. It's much more easier, less headache. And other than that, we also use a lot of Lambdas as part of our Microservices. All those lightweight applications, we use Lambdas. As for what else? Yeah. Okay, I hope that answers your question. What else? Do you see? Okay. All right, cool. Do we have any other questions? Okay. Okay, great. Okay, then. Yeah, so if you have any other questions, or if you would like to reach out to me, or you would like to learn something new, or you want to clarify some of the answers, feel free to email me. Maybe put in the keyword webinar in the email so I can filter them down. Join the Facebook group, please do. Thank you very much. I guess if there are no other questions, we can wrap it up. Yep. Okay, so there's a message to fill up the what do you call the feedback form. All right. Thank you, everyone. I'll be signing off right now. Have a good day and stay safe.